Welcome back, everybody, for another deep dive with us. Today, we're going to kind of take a trip back in time to 2003, when a true pioneer in computer science was honored with the prestigious Benjamin Franklin Medal.
Oh, wow.
In computer and cognitive science.
I like that, computer and cognitive science.
It's a pretty cool, cool award.
It's a good one, yeah.
And we're talking about...
Who are we talking about?
Dr. John McCarthy.
Oh, yeah.
And his work is just incredibly relevant.
I think even more so today with the rise of AI.
Absolutely.
Yeah.
And his contributions go way beyond just artificial intelligence.
Go way beyond.
He's credited with things like computer time sharing. And he even coined the term artificial intelligence.
Yeah.
And
to
fully grasp his impact.
Okay.
We're going to be looking at an article written by William L. Weaver, and this was published in Scientific Computing and Instrumentation back in July of 2003.
Okay.
So a while ago.
Wow.
But it's really interesting. What's fascinating about this article
tell me about it.
Is that it dives into a language that McCarthy developed called LISP.
LISP.
Which stands for Lisp processing.
Okay, Lisp processing.
Back in the late 1950s.
Oh, wow.
When Fortran was the dominant language.
Which is all about numbers.
And focusing heavily on numerical calculations. LISP was revolutionary.
I can see that already.
Yeah.
So it was revolutionary because...
It was so different.
It was so different from what was...
It had a completely different approach.
Fortran was kind of like a really powerful calculator. Like it was crunching numbers.
Yeah.
But McCarthy came from a math background.
Yeah.
But he was interested in...
symbolic logic. And how to represent knowledge in a way that computers could understand. So that's where LISP came in.
So LISP was kind of like a thinking language.
Yeah. I mean, it was like instead of just working with numbers, it was about manipulating symbols and ideas. Kind of like how we think as humans.
Okay, yeah.
It's a huge shift.
It was a huge shift.
One of the key innovations of LISP was its use of lists to represent data.
Lists?
Yeah.
Okay.
Imagine building blocks of information.
Okay.
That could be combined and manipulated in incredibly flexible ways.
Legos.
Yeah, kind of like Legos.
Okay, I got it.
Yeah.
So instead of adding or subtracting numbers, you could have a list of concepts like a cat mammal pet.
Mammal pet.
And then use LISP to...
Yeah, and then you could define the relationships between them.
I see, I see.
This ability to manipulate symbols and relationships opened up a whole new world.
A whole new world.
Of possibilities.
Yeah. Of possibilities?
For programming.
Okay.
Particularly in the field of AI.
Ah, I see that.
So the article mentions 9 key concepts that LISP introduced.
9 key concepts.
And one that really stands out to me is the simple if-then-else statement.
Oh, that's interesting because...
it's so basic.
That's like the basis of so much.
But back then, it was groundbreaking.
Oh, wow.
And it's really the fundamental logic behind so much of what we do with computers today.
I guess that makes sense. Like, if this happens, then do that.
Yeah,
otherwise, do this.
If this, then that. Otherwise, this.
Yeah.
It's essential for decision-making in programs.
I can see how that would be kind of revolutionary.
It's amazing how such a simple concept can have such a profound impact.
Yeah.
So we've talked about lists and if-then-else.
Yeah.
But the article also dives into something called recursion.
Recursion.
What exactly is that?
What is that?
And how does it relate to LISP?
I don't know. Tell me.
Well, think about those Russian nesting dolls.
Okay.
You open one up and there's a smaller, similar doll inside, and so on and so on.
Okay.
That's a lot like recursion.
I see that.
It's the idea of a function calling itself within its own definition to break down a problem into smaller, self-similar pieces.
That's wild.
Yeah, it's a little mind-bending.
Yeah. But the nesting dolls.
Yes, the nesting dolls.
It really
helps to visualize it.
Okay, I get it.
So can you give me a real-world example?
I need a real-world example, yeah.
Imagine you want to calculate the factorial of a number.
Factorial?
Yeah. Let's say 4 factorial.
Okay.
Which is written as 4 with an exclamation point.
Right.
This means 4 multiplied by 3.
Oh, okay.
Then 2.
Times 2.
Then 1.
Okay.
In LISP, you could define the factorial function.
Okay.
Recursively.
Oh, recursively.
It would essentially say, to calculate the factorial of a number, multiply that number by the factorial of the number minus 1.
Okay.
And it keeps calling itself.
It keeps calling itself.
Like smaller numbers until it gets down to 1.
Oh, that's neat.
So it's like the function keeps opening smaller nesting dolls.
Right.
Until it gets to the smallest one.
Yeah.
And then it can work its way back up. To solve the original problem.
I like that.
Yeah. And this concept of recursion.
Yeah.
First explored in LISP. Has become a fundamental programming technique. Used in countless applications today.
Oh, wow.
It's incredible how LISP developed in the 1950s, introduced concepts that are still relevant and widely used in modern programming languages like Java and Python. It really highlights how groundbreaking McCarthy's work was.
Yeah, I mean, that's wild.
But the story of LISP...
The story continues.
It doesn't end there.
It doesn't end there.
There's this misconception.
That
it's obsolete.
Oh, really?
But it's actually experiencing a resurgence.
Oh, wow.
Really?
Why is that? Well, as AI and machine learning become more sophisticated, there's this growing need for ways to represent knowledge and relationships in a way that machines can understand.
Yeah.
And LISP's focus on symbolic logic and its ability to manipulate lists make it a really powerful tool for building these complex AI systems.
So it's not just about crunching numbers anymore. It's
more about teaching computers to think like us.
Like us, yeah.
Yeah.
Yeah, it's
but
like...
How do we think?
It makes me think about the way we teach kids language.
Okay.
We don't just throw a dictionary at them.
Right.
We help them understand the structure of language, the grammar, the relationships between words.
Yeah.
Is that kind of what LISP is doing for computers?
Yeah, that's a fantastic analogy.
Yeah.
And this focus on the structure of language was central to one of McCarthy's later projects, which the article touches upon, a language called Elephant 2000.
Elephant 2000.
Yeah.
What a unique name.
I know, right?
What was the goal of this language?
Well, McCarthy envisioned Elephant 2000 as a language that could truly understand the way humans speak and write.
Okay.
It was designed to parse natural language syntax.
Okay.
Meaning it could break down sentences into their component parts and understand the relationships between them.
Oh, wow. So instead of having to type in commands or click on icons, we could just talk to computers naturally.
Yeah, it was the idea.
That sounds like something straight out of science fiction.
It does, right.
But surely there must have been immense challenges in trying to create a language.
Oh, I mean, huge.
That could truly understand the complexities of human language.
Yeah, I mean, think about it.
We often struggle to understand each other.
We do, exactly.
So how can we expect a computer to do it?
So how can we expect a computer to do it?
It's a great point.
Yeah, and natural language.
Oh, it's so messy.
It's so messy.
It's filled with ambiguity, sarcasm, humor,
bring along,
cultural references, all things that are incredibly difficult for computers to grasp.
Incredibly difficult.
Yeah.
But the fact that McCarthy was even tackling this problem back then speaks volumes about his visionary thinking.
It's like he was laying the groundwork for the future of human-computer interaction.
Yeah, he was ahead of his time.
And in a way, he was.
Yeah.
Because even though Elephant 2000 never quite materialized as a fully functional language, the concepts he explored continue to influence research in natural language processing and AI.
Absolutely.
So the challenges he identified are still being addressed today as researchers are trying to develop AI systems that can understand and respond to human language in a more natural and intuitive way.
It's really fascinating to see how these ideas kind of keep
coming back around.
It's a reminder that innovation is often an iterative process.
Yeah.
We build upon the ideas
of those who came before
us, tackling new challenges.
New challenges,
and pushing the boundaries of what's possible.
That's right.
Speaking of pushing boundaries,
the
article highlights how LISP is being used today in ways that McCarthy might not have even imagined back in the 1950s. Really, I thought we were talking about a language that was considered...
so outdated.
Outdated.
Yeah. That's a common misconception.
Okay.
LISP is experiencing a resurgence.
Okay.
Particularly in areas like rapid prototyping and bottom-up development.
Okay, so what does that even mean?
So, like, it's flexible.
Okay.
And it has this expressive power
Mm-hmm.
that make it ideal for quickly building complex systems.
Okay.
Especially in fields like AI and machine learning.
So even though it's an older language,
It's an older language.
it's still relevant and powerful
Yeah.
in today's tech landscape.
Yeah.
That's remarkable.
It is. And what's even more fascinating
Okay.
is that LISP's resurgence kind of aligns
All right.
with a broader trend in AI.
Okay.
A renewed interest in symbolic AI.
Okay.
The approach that McCarthy championed.
Right. Representing knowledge explicitly.
Explicit.
Using symbols and relationships.
Yeah, symbols and relationships.
Yeah. But how does this approach compare to other AI methods that rely on these massive data sets?
Well, think of it this way.
Okay.
Data-driven approaches are like training a dog.
Okay.
You give it tons of examples,
Mm-hmm.
and it learns to recognize patterns.
Okay.
Symbolic AI, on the other hand,
Yeah.
is like teaching a child.
Okay.
You explain the rules.
Right. The logic, the relationships between things.
So symbolic AI is about understanding the why behind things,
That's it.
not just recognizing patterns.
Exactly.
Yeah.
And this deeper understanding can be crucial
Yeah.
for building AI systems
Right.
that are not just good at performing specific tasks,
Right.
but can also reason,
Yeah.
adapt, and
Great
even
point.
explain their decisions.
It seems like we're at this
Kind of a turning point.
pivotal moment in AI development where different approaches are converging.
Right.
We have the power of these data-driven methods,
Mm-hmm.
but we also need the ability
Yeah.
to represent and reason about knowledge
Right.
in a more human-like way.
More human-like. And
Yeah.
that's where the legacy of John McCarthy and LISP continues to shine.
Yeah,
His work really paved the way
it did.
for a deeper understanding of how to
Yeah.
represent knowledge and build intelligent systems.
It's fascinating to think that a language
Well,
developed in the 1950s
Yeah.
is still influencing
The
the
50s.
development of AI today.
It's wild.
What do you think McCarthy would make of the AI landscape now?
Oh, gosh.
With things like self-driving cars,
Yeah.
virtual assistants.
It's hard to say.
Yeah.
But I think he'd be both excited
Right.
and perhaps a bit cautious.
Yeah.
He always emphasized the importance
Yeah.
of building AI systems
Mm-hmm.
that are not only intelligent,
Right.
but also beneficial to humanity.
Right.
He was a strong advocate for
Yeah.
ethical considerations.
It's so important.
Oh,
As we
nice.
develop
Yeah.
increasingly powerful AI systems,
Right.
we need to be mindful of the potential consequences.
Yeah. It's not just about making machines smarter.
Okay.
It's about making sure
Yeah.
they're used for good.
For good. Yeah, that they're used ethically.
Ethically, yeah.
Well, before we get too far down that rabbit hole,
Okay,
let's bring it back to the article
back to the article.
that sparked this whole discussion.
Okay.
It was written by William L. Weaver,
William L. Weaver.
who, interestingly enough, is not a computer scientist.
Oh, really?
He's actually a chemist.
Oh, wow. That's
He
interesting.
holds a PhD in analytical chemistry
Okay.
and teaches at LaSalle University.
Wow.
It's a testament to the impact of McCarthy's work
Right.
that it could resonate with someone outside of
Outside of the field.
the traditional computer science world.
That's so cool.
It just goes to show that groundbreaking ideas
Yeah.
can transcend disciplines
Mm-hmm.
and inspire people
Yeah.
from all walks of life.
I like that.
So what does this all mean for you,
Yeah.
our listener?
Our listener,
If a language developed over half a century ago
over half a century ago.
is still relevant today
Yeah.
and influencing cutting-edge technologies,
Right.
what does that tell us about the enduring power of ideas
Wow.
and the importance of understanding the foundations of intelligence,
Foundations.
both human and artificial?
That's a good question.
It's a lot to think about.
It is a lot to think about.
But that's what these deep dives are all about.
They are.
So thank you for joining us.
Thank you for having me.
And we will see you next time.
See you next time.